In this video, we'll be looking at how you can import and export 3D data into our Vectric software, and we'll begin by looking at the various file formats that you can import into VCarve and Aspire, and then later on we'll cover file formats that can only be exported into Aspire. To begin with though, we'll need to start with a new job, so let's have a look at our first example. Okay, so now that we're in the software, our job is a single-sided job, 10 by 10, thickness of 1 inch, Z0 for the material surface, XY in the bottom left, and we're using a very high modeling resolution because we're working with models. So let's click OK, and now I want you to keep one thing in mind here, which is this section here, the 3D model tools. Now we're going to be using VCarve Desktop and Aspire in this video, and you'll notice that there's a difference between the two because Aspire has far more modeling tools than VCarve Desktop does. So do keep this in mind because we'll be looking at Aspire later and some of the tools later on as well. But for now, we're going to pop over to the Clipart tab and we're going to look at some of the clip art in the software and some of the ways that you can import it into the software. Now you can see here I've downloaded some clip art, but they're organized by sections over here on the left hand side. So I can click on the clip art folder here and it gives me the subsequent clip art folders that are stored on my PC where it loads the clip art from. So these are .v3m files which are specifically made to use with our software. And what I can do is I can click and drag these onto our worksheet here. So let's go over to our 3D view, and you can see if I click on one of my sections, for example, if I go to objects and people, I've got clip art related to that subject matter under objects and people, and the same applies if I go for ribbons and banners, etc. So you can actually find your clip art on your V&Co account, and there will be a related video on how to download your clip art and how to access your clip art in the comment section below. But for now, what I'm going to do is I'm going to show you how we can bring in some of this clip art. So if I just double mouse click on the crown here, you'll see that it brings it into the center of the workspace, and if I delete that, I can now go ahead and bring in a crown by left mouse clicking and just simply dragging it onto the worksheet where I want it, letting go of left mouse click, and it brings it into the worksheet so we can now manipulate it. So you've got the transform icons here, so you can just drag this out, make it larger, smaller, and do various changes to it, rotate it if you want to as well using the rotation handle here, so you can rotate your crown around if you want to. So you can make some edits to it as well. And you'll notice that there's also different varieties of the clip art. You'll notice that we've got 3 for the crown here, 3 for the decorative pieces here, etc. So you get a lot of varied choice with these clip art. Another thing to note here is that you can click this button here to add folder, because if you've got any clip art from an external source outside of the clip art that you've got within the software or available on your V&Co account, you can click this and add in a folder where you store that clip art. So if you click this brings up the folder explorer here, so you can look at importing a folder. So you can click on a folder. For example, let's say I imported some external clip art and put it into my borders folder. I can now select that, click OK, and that will bring it in over to the left hand side here, so I can now access it. So when I come over to borders and I can click on it, what will happen is it will show anything that I've added new in there under here as well. And now if I delete out my crown, what I'm going to do is just go one other way to bring in clip art, which is to hover your mouse over the clip art. You want right mouse click, import to level, and you can import it to the current level, or you can import it to a new level if you want to import that to a new level. So I can just do that if I want to. So I'll go to level 1, and that will now import the crown onto level 1 there for me. But with that covered, we're now going to delete the crown, and we're going to move on to the next section and import some 3D data of our own. So we're going to go over to the design tab, and we're going to click on this button up here to import a component or 3D model. So let's click on that. And you can see here I've got 2 files. I've got a flow.delete.v3m file, and we've got a Porsche STL. And if you're wondering what kind of 3D files you can import into the software, if you come down to the bottom right here, you can click this list and you can see the various types of files that we can import into the software, but you can actually find the definitive list on our website. So if you go onto our website, you can find the definitive list of files that you can import. But for now, what we can do is we can double click this or click on it once and click open, and we can bring this in, and this will bring in the 3D file to the origin point, which is what we set earlier in the job setup sheet, which was the bottom left corner. But we can move this around by dragging it and with the transform handles, and we can manipulate it, edit it as we need to for our particular design. But for now, I'm going to delete that, and we're going to have a look at another example. So let's come back up to import a component or 3D model, and this time we're going to choose the Porsche file. So let's double click on the STL file, and you can see how now it's brought it in with the import form here in the top left. Now before we go any further, I'm just going to change the size down just a little bit so we can get it to fit within our job sheet. There we go, that looks a little bit better, so we can have more visibility of what is going on here. Because you can see this red box that represents our material here, which is the 10 by 10 that we had set up earlier, so we want to make sure that our model is around about that kind of size. Okay, so in the top here we've got the initial orientation. Now currently it's set for the Porsche to be the top facing upwards, but we can change that. So we can click on right, we can click on front, bottom, left, back, top again. But this time I'm just going to go to bottom so I can show you something that's quite important here. And that is that the orientation that you pick here will essentially be facing upwards. And now why is this important? Well, that's important because this is where the most detail will be cut from on the machine, because the machine will be coming effectively down in Z here to cut onto that. So we want the most detail to be facing upwards or to the top here, so we can get the most detail out of the machine, because that is where the cutter is coming from. So in this case, you can see we've got a large flat area with our bottom side. So we don't really need that because that's not going to get the most detail out of it. So in this case, top might be a good option, but upon further viewing, I think front might be best, because if we're coming down with a tool, we can actually cut this in two halves potentially. We can go into that a little bit later, but we can come down with the tool onto the side here. We can get the majority of the detail, the wheels, etc. here, because with the top and the bottom, you're not really going to get much details for the wheels, but with the front, we can achieve some of that detail there. Now you can also come over and use these handles here, so the red, the green, and the blue one, to orientate this. So you can click on these and you can drag, and you can see this one pulls this around towards us and away from us, so you can rotate this. With the green one, you can rotate this in this direction, this orientation, and then with the blue one, we can spin this round this way as well. So it just gives you a bit more control over where you want to place your model. But in this case, I'm actually quite happy with front, so I want to keep it in the front for the moment, or the front orientation. I can also rotate around the Z-axis, so if I just get that into view and I click on -180, 90 or -90, +90, +180. I'm happy with 0 at the moment, so let's go on to the next section of the form. Now you notice that currently the model size is actually a little bit larger than my worksheet, so let's address that. So first thing, I want to change the X-axis, which is in this case the length of the car. We've got the Z-axis as well, which is the thickness, and the Y-axis, which is the width. Now what I'm going to do is I'm going to change this down to 9 and then hit apply. And you notice that it scaled it down appropriately. That's because I've got lock X, Y, and Z ratio on. So what that means is if I change any one of these values, the other two will be affected. So if I change Y, X and Z will be changed. If I change Z, X and Y will be changed, etc. So they're linked together. Now maybe a scenario where you want to change only one of these axes, like say for example we turn that off and I change X to 4, and we can see what happens. We hit apply, Z and Y stay the same, but now you can see that in X my Porsche has been squashed and it doesn't look very good. So I'm going to put that back to 9, but just to show you an example of how you can amend one axis specifically if you want to. I'm going to turn the ratio back on. And then we have the next section for the units. So we've got millimeters and inches, and we've got center model and scale millimeters and inches. Now, STL files don't generally tell the software what units they were actually created in, only just a series of numbers. So sometimes we do have to tell the software what units the original file was designed for. For example, this is now currently set to 9 inches, but I can just set this to be 9 millimeters wide if I want to, and you'll see it's totally squashed down the model to 9 millimeters, but I don't want that. In this case, I want it to be inches. I can also scale the model in millimeters and inches. Let me just center my model first. Let's center that back in. If I click this button, what it'll do is it'll scale it appropriately. So now it's gone to 9 millimeters, which is represented in inches here because we're working in inches. So this is the inch variant of the 9 mil, and if I click that again, it'll go back to what it should be, which is the 9 inches. In fact, I can just scale that back up again. But with that covered, let's click on position and import. So let's click on that. So as you can see here, we've got this new element in the 3D view to consider. That is the position that the model is relative to the modeling plane of the software. So as you can see here, that's controlled by this slider. So yeah, I can slide this up and down. Let me just put this into view here by right mouse clicking and dragging. So here's our plane. We can drag this up and down relative to our plane here. Now you can actually edit the value here if you want to, so you can manually enter a value. So if I put in 1, for example, and click enter, you'll notice it's put it down to that value. So it's put it down to 1. The depth below top is 1. You can also use this option here to discard data below the 0 plane. What does that mean? Well, here's your plane here, it represented in blue. So any data that is underneath that plane will be discarded. So in this case, pretty much half of the car will be gone. So if I slide this now down, you'll notice that now all of the car will be represented because it's above the plane. If I did the opposite, what would happen here is that you would have no model import effectively because there's nothing to bring in, because it would be any data below that plane will be discarded. So let's put that back into the middle for now, because what I want to do is I want to use this option here to create both sides. as we're planning to make a two-sided model out of this in two separate sections in our single-sided job. We do have another video which is based on a two-sided job which follows many of the same steps, so please check it out in the related videos. But I want to make sure that the plane here is in the center of our model so both sides are equal in height. So we can actually just come up here and double click on the dashed lines next to the slider. So if I double click on the top here, it brings it all the way to the bottom. Double click on the bottom, brings it all the way to the top. And if I double click in the middle, that brings it into the middle, which is where I want that to be. And at this stage, I should also point out that if you are importing a 3D model which doesn't have any details on the back side, you'd want to make sure to turn off the create both sides option here, and then move the modeling plane slider as low as it can go, because this will ensure that the detail of the 3D model will be incorporated into your 3D component. And we can also use this option here to highlight undercuts. Now what happens when I click that is, you notice in the software it's now highlighted in purple or pink areas in which the tool will not be able to reach when it's trying to cut, such as the details inside these wheel arches here. You can see the tool wouldn't be unable to cut the underside of these spokes, and in many cases won't actually affect the final cut, but it does help you to identify some potentially problematic areas in your design. If I turn off the create both sides option, you'll notice that the software will actually highlight even more areas potentially, because now it's only just thinking about cutting down from above rather than just splitting the model in half. But let's create both sides again, and we'll import this as it is. Now, as you can see upon import, it looks like a bit of a mess, and that's because the two sides of the car have been imported on top of each other. So what we can do is we can tile our views, and I can show you what that looks like in both views. So in 2D view, you can see that there's the one half and there's the other half. They're just on top of each other. So what we can actually do is in the 2D view or the 3D view, we can just left mouse click on it twice, and we can drag one of these parts further up or further down. So let's pop that just down there for the moment. And we'll do the same for the other one. We'll drag that up just a wee bit, just to separate them out a little bit. And there we are. You can see that the both halves have now been imported. So let's maximize our 3D view again so we can have a closer look at what we have imported here. So if I just right mouse click in 3D view and hold control on the keyboard, I can bring up the car into view here, and I can zoom in with the mouse scroll wheel, and I can just tilt this a little bit with the right mouse click. And you can see here that the 3D model has retained all the original detail, including the polygonization of these wheel arches, making it look quite rough in our 3D file. And this is unavoidable because we're importing the 3D model exactly as it was originally created. So if we wanted to change this, we want to go back to the original model and clean it up in our original 3D modeling software before importing it to our software for a better finish. We can't just use a smoothing filter either. So for example, if I select this and go over to the smoothing filter, if I apply a filter, let's say just a little one, so if I click over here, while you'll notice the wheel arches are a little bit smoother, you're losing some of the detail on the wheels there, for example. So let's just close that out. Another thing to keep your eye on is anything that involves undercuts, since it's not possible for a CNC machine or 3-axis CNC machine to cut underneath a part of your model, since it would have to cut through from the top. So certain elements become merged with anything else that's below them. So in this case, if we look at the wing mirrors here, so if I just zoom this into view and bring this across over here, you'll notice that the wing mirrors have merged with the window that's underneath them. So likewise, if we move to the front of the car, if we just bring that into view, I'll zoom out just a little bit so you can have a look at that. You can see that the lights are also experiencing a similar effect there, where the front lights are no longer separated from the body and now a single straight line down across the bonnet. And you also notice that with the wheels as well. So if we go over to the wheels, you can see just underneath here that it does a similar thing. Now if I go back to the top-down view again, you'll also notice we have a similar thing going on with the aerial for the car here, as it's going down to a straight line as well. So these are the kind of things that you need to address before moving on with your cuts. Now if I just pop that back into view, it's important to note here that with Aspire users can look at reducing the amount of undercuts using segmenting 3D models. So this segmenting feature allows the model to be broken up into several parts, so you can help minimize the amount of undercuts. So for more information on that, please look at the video on segmenting data, which will be one of the related videos for us. But now what we're going to do is go over to the Components tab, and you'll notice that we can also come up to our model and we can right mouse click on one of them, and we can choose to re-import. So this option allows you to return to the import 3D model positioning panel, so you can make small adjustments before then importing it. So you can do that with new settings rather than having to delete the 3D model and then import a new version of it from scratch. So I'm going to cancel that for now though, but now you can plan out some 3D toolpaths and a profile cutout toolpath to cut these two parts out and then glue them together to create a simple car design model. Okay, so let's move on to the next element of the video, which is going to be in the Spire. So we're going to talk about the additional features and options it has for 3D imports. So you can see I've got a single-sided job here, width of 10, height of 10, thickness 0.5, Z0 of material surface, XY in the bottom left, and the modeling resolution, again, set to very high because we're using models. So let's click OK. And you'll notice that right away we've got far more modeling tools in Aspire here in the design tab. And if I just go over to our 3D view, because we'll be using some models, let's have a look at looking at some files. So the first thing we're going to do is look at the difference between CRV3D files and 3D clip files, both which Aspire can use here. So if we pop up to the Import Component 3D Model tool up here, you can see I've got one file here which is a 3D clip file, and I've got one file here which is a CRV3D file. You can see the file extension just there, and by hovering your mouse over it, you can see the file as well. But I'm just going to double click on the CRV3D file to bring that in. So you can see here that we've got our 3D component, which was that original project imported as a new 3D component in our new project that we have here. Now, if I just bring that up to the right here, so we can place it here, so we can have a look at that in just a moment. I'm going to come back up to the import component or 3D model, and we're going to choose our clip file this time, so our flow delete clip file. And that brings it in, and we'll just drag it up here as well, and we'll just place that in the middle there. Now, if we hop over to our components tab, you're going to see they're actually imported slightly differently. You can actually see that the original one from the CRV3D file here is actually just one component, whereas the 3D clip file is actually made up of a series of components. You can see in the component tree. So if I just turn off a component for the flow delete that we brought in from a CRV3D file, it's one unit, it turns off and on. Whereas if I go into my 3D clip file, I can turn off smaller segments of that component, so you can see how you have more control over that. So this way, if you export your designs as 3D clip files, you can keep them as their separate elements for future work in larger projects with your clip art that you have created. And we'll actually be covering how to export 3D data later on in the video, but for now let's just select all of our models we don't need anymore. We can delete these out because we're actually going to look at a different option on the design tab now. We're going to look at this option just here to create a component from selected or imported bitmap. Now, we're going to learn how to import a 2D bitmap and convert it into a 3D component. You can use this on a bitmap that you've already have in your project and use this to create a component from the selected bitmap tool. Or you can use this to actually import a bitmap directly as a 3D component. This works best with 3D scale height map images. So if we open this up here, you can see one in front of you, which is this one just here, our test.tif file or TIFF file. And let's bring that in, shall we? So let's double click that, and then let's tile our view so we can see the 2D view and 3D view. So you can see the grayscale image here, but you can see the model that has been created from it in the 3D view over here. So you can see how the 3D image here looks very similar to our original fleur de lis that we were working with, and because of the special way that grayscale height maps are created, it allows it to create 3D items from just a 2D picture, which is not possible, unfortunately, from normal photos. So for now, what we can do is delete this. And then what we can do is have a look at importing another bitmap. And what we can actually do is this time we can just use the import bitmap option. And we can actually use the post option here, and you'll notice it brings it in as just a bitmap, nothing special at the moment. But if we go over to the tool here to create a component from selected or imported bitmap and click that, it now creates a component from that. So you can do it two ways. You can either import the bitmap and then use the tool, or you can use the tool to directly import it and create it for you. As you can see here, our 3D component doesn't look like a 3D model of a wooden post, but it still does look like we could use this as a texture as part of a larger project, as this is a 3D component in its own right. And another thing that we can do is actually get rid of the bitmap, because we don't need this anymore because we've created the component. So if you notice on the 2D view, if I move the bitmap out of the way, the component is actually underneath it there. So I can delete that because I don't need it anymore. And similarly, if we go over to the components tab, we can actually have a look at now editing or adjusting our components. So we can right mouse click it, we can change the combine mode, for example, to subtract or merge or low or multiply. We can also do it in the 3D view. If I right mouse click on the component, go to component, choose subtract, I could then put it back to add if wanted, so it adds on to anything else. And then I could actually use this as a texture overlay. So for example, if I go over to my Clipart tab and I bring in an apple, for example, and I drop this onto the workspace, if I now go back to my components tab and I move this on below the post, you notice how it applies that texture over the apple here. So you notice this, the section where it intersects, it applies that as a texture over that apple section there. So if I just size the apple down or up, you can see how it applies it to just that section. There we are, of just that part of the apple. So you can achieve some really interesting results by playing around with some of these settings. And now we can look at another example. So let's just go ahead and delete these components. We can delete those out, and we'll come back over to the design tab. We'll go to create a component from selected or imported bitmap. We're going to do it directly from the bitmap this time. So we're not going to import the bitmap first. We're actually just going to select it from this menu. And you can see if I double mouse click that, it brings it in and then immediately creates the component for it. Now if I zoom in on 3D view, you can see here that the 3D quality for carving a low relief doesn't have much of a 3D quality to it. But it has picked up the different gradients and textures of the original picture. We could probably apply a little bit of smoothing to this if we wanted to take off some of the sharpness on the corners. So you could just select that and come over to the smoothing tool here. And we could just apply a little bit of smoothing just to get rid of some of the sharpness on the corners. And then we can click OK. And then what we could do is perhaps use this for a lithophane carving. But it's important to remember that the quality of the 3D component you create from your bitmap images that you import do entirely depend upon the quality of the original picture. So if you have a low quality JPEG image, for example, you'll get some artifacting which will appear in the final piece that you create, whereas if you use a higher quality format such as a PNG, for example, you might get better results, particularly with a larger picture. So now that we've gone through a number of ways that you can import 3D data into VCarve and Aspire, let's talk about how you can export some 3D data from Aspire. So I'm just going to delete what we have created so far so we can get rid of all of that. Then we're just going to maximize our 3D view. And now what we're going to look at is, let's say we had a section of the 3D component that we had in one project and we wanted to reuse it for a future project. Well, that's what we're going to look at doing right now. So let's go to import a component or 3D model again. And this time we're going to use the fleur-de-lis clip file that we used earlier, the 3D clip file. Let's double click on that, let's bring it in. And then we're going to just bring that into the center of our job. Let's pop that in there. And then we'll go over to the components tree over here. Now you can see here I can turn off the different sections of the fleur-de-lis because, as we said earlier, it's a 3D clip file, so it retained all the individual components. But let's say if I just wanted the center fleur here as its own clip art file and I wanted to export that out. Well, what I need to do first is I need to separate it out from the group here because it's currently grouped together. So if I right mouse click and choose ungroup, they're now their own individual components. Then I can choose right mouse click on the center fleur and I can go to export as 3D clip art. And you'll notice it takes the component name as the name for the 3D clip file, but I'm happy with that for the moment. So I can click save, and now that's saved it out as its own separate component, so I can use that later on and I can import that back into a new project. And we can actually do that right now. So if we go back to our design tab and go to import a component or 3D model, you'll notice here's our center fleur. So we can double click that to bring it in, and I can now move that around, adjust it as needed, edit it, whatever I need to do with it. So it's its own 3D clip file here that I can now import and use in other projects, but I'm just going to delete that for now. And then what we'll do is we'll go into the components tree again. So now what we'll look at is if you wanted to export these as a group. So what you can do is you can hold shift and you can click the bottom component and the top one, and it'll highlight all the ones in between, or you could manually left mouse click by holding shift and select all these, right mouse click and then choose to group. And then what you want to do is right mouse click the group, export as 3D clip art, and then you can save this out. Now I'm not going to do that here because I've already got it saved out here from earlier. However, you can do that if you want to have a group of components saved off together. Now, next we're going to look at exporting the selected group of components as an STL file. So if we go over to the design tab, we've got this tool at the top here which says export visible model as an STL file. So let's select our component. Let's go up to the export visible model as STL tool, and what we'll do is we'll just click on triangulate just to see what we're working with at first. So you can see here we've created an STL mesh in the software, and it's currently got an open back, and you can see that it's made up of a number of polygons you can see here. Now you can increase the tolerance of the 3D model by changing the tolerance value here. So if we change that to a lower value, for example, and then click triangulate again, you'll notice it's a lot smoother this time, so it's smoother in the result here. You'll also notice that down here we've got the number of number of triangles created, so tri is short for triangle. and it says 34,844, but if we increase the tolerance and triangulate, you'll notice it has less triangles. So you can get a higher quality STL file by decreasing the tolerance value, but at the expense of creating a larger file at the end. Now you can actually use the maximum number of triangles here as the measure of quality of your final file. So if I leave it at 50,000, for example, and I click triangulate, we can have a look at the file, and it's clearly a lot smoother there, but we will have a larger file, and it's used 50,000 triangles to actually create this file. The next option here we have is to leave the back open, so we can see here that the back is currently open or hollow, and then we can close it with an inverted front. So if I click triangulate again, this time you'll see the mirror of the front here, so it's closed it, so it looks like a full 3D model now. And if I close it with a flat plane, it closes it with a flat plane, so let's just triangulate that again. And there you go, so it's flat there on the back, you can see there for that option. So depending on what you want to use your 3D model for, that will likely determine what sort of back face is suitable for your design. So once we have set up our STL export as we want and the quality is suitable within our 3D view, we can then click on Save Triangulation to save this STL file. So in this case, I'm just going to call this one Fleur. And you'll notice I can save it as an STL file, a OBJ file, or a POV file, but in this case, one STL. I'll click save, and that's now saved for future use, so I can import that back into the software. So I can close that down. Let's tile our views again. Let's look top down onto our views. And so for the final task, what we're going to do is save our 3D component as a special grayscale height map. So what we'll do is we'll go over to the components tree and we'll select our group of components by clicking on the group. We'll come to model, and we're going to choose this option here to export as a grayscale bitmap. Now in this case, I'm going to call this one bitmap, and then you can see here that we can save it as various file types here. So you've got Windows bitmap file, a JPEG image, a GIF image, a PNG file, or a 16-bit TIFF file. Now when working with 3D height maps, I'll typically either use the bitmap, PNG, or TIFF formats, as these contain the highest quality images for 2D images. So I'll save it as a PNG for the moment, and what I'll do is just click save. So now if I go back to the design menu and I click on this button here to create a component from selected or imported bitmap, you'll notice that my bitmap's here, and I can double click that to open it and it'll bring it into the software. Let's just bring that over to the center of our worksheet, and let's just scale that down just a little bit. But you can see it's brought it in, and we've successfully managed to export it so we can use it in a different project. But I'm just going to delete that for now, and that concludes our tutorial on how to import and export 3D data in VCarve and Aspire. I hope you've enjoyed it, and we look forward to seeing you in the next video.